Hot wheel friction lab. The purpose: I will find the force of friction between a track and the non-rotating wheels of a toy car. Relevance: this activity will combine skills that were learned in previous labs. Success: I will compare my conclusions with those of my classmates and the teacher. Instead of reading the general idea, let me show you. Here is the setup over here. We're going to be placing a photo gate at a position on the flat area. And we have two cars here. They have magnets on their back ends so that when they collide, they'll stick together and slide as a single unit. One of the cars has wheels that are glued shut so that they don't rotate at all. This thing is forced to slide, and it's the sliding that's going to bring these to a halt. I put the one with the glued wheels right in front of the photo gate. I'll show you a little bit better here. We want to make sure that the car has its bumper right even with the beginning of the tunnel. But I'm going to put it up closer to the slope here so I get better speeds. And then I'm going to roll the other car down backwards so that the magnets hit each other and they slide as one unit. As you can see, they don't slide very far, but they do get through the photo gate, and they do register the initial speed. We're going to be able to take some measurements there and figure out how much force the friction supplied in order to bring those cars to a stop. Okay, with that in mind, let's read this paragraph here for the general idea. There will be two toy cars on a track. One ordinary car rolls down from the top. A second car is sitting still at the bottom. This second car has its wheels glued in position. They don't rotate, but the car can slide on the track. When the first car rolls into the second, they will both skid forward for a short distance. By taking the appropriate measurements and using the right equations, you can find the force that slowed the vehicles to a stop. One of the materials is a photo gate. Remember that when you put in the batteries for this, it first shows up a clock, and to get it into the photo gate mode, you hold the button down for 2 seconds, and it starts flashing kilometers per hour down there, and we get 0, 0. When the car moves through it, it breaks the beam between these two light sensors, and it registers the speed in kilometers per hour. On the side, there's a note that says multiply this kilometers per hour by 0.277, and that will give you the meters per second. In order to reset this, you just hit the blue button again, and the flashing light down here indicates that it's ready to go. The other materials that you'll need are either a meter stick or a ruler. Let's have our measurements in meters, please. Remember that if something moves 3 centimeters, that is going to be 0.03 meters. If it moves 12 centimeters, that would be 0.12 meters. So you're moving the decimal point over 2 places to convert. Then we also have the track, and we have the 2 cars. Proposed procedure. There are 2 ways of doing this. I will let you decide which way you want. One way we have the initial car right even with the beginning of the tunnel. Car slides down from the top and slams into it. They both slide, and you videotape this on your phones. Afterwards, after the collision, we're going to end up with the photo gate here and at least some of the cars poking out. And by viewing the video with a timer at the bottom, you can find out how long it takes the car to come to a stop. Now this only works if the timer on your video editor reads to the 0.1 or the tenths of a second. If your editor only shows it in seconds, you're not going to have enough accuracy in order to do these calculations. But if you can tell to the nearest tenth of a second how long it takes, it's going to work out great. Then we use our impulse equation. We're looking for the F. The T is from your video editor. The M is the mass of both cars. There's a triple beam balance in the middle of the room. The VF is going to always be 0. They come to a stop. The VI, that is the photo gate. Remember, it needs to be in meters per second. For the mass, you need to have that in kilograms. So if your car, both cars have a mass of 50 grams, that's going to be 0.050 kilograms. If it was 75 grams for both cars, then converting would be 0.075 kilograms. Okay, so that would get us all the numbers except for the F. And so you could do multiple trials, record the values of these things, and use the equation to solve for F, and then find the average for all of those F's. A second procedure. We can use all of these equations to come up with a single equation that relates the skid distance to the friction force. If you don't have a video editor that has the tenths of a second, using a stopwatch isn't a really good idea because this happens so quickly. Our reaction error is going to be really, really significant, and so that would not be good. I'm going to skip the derivation, but I could put all of these equations together and make a new equation that looks like this. F equals mv squared, vi squared, all divided by 2 delta x. So this is the force of friction that we're trying to find. The m is the mass of both cars, again in kilograms. The delta x is the skid distance, and that has to be in meters. And the vi is the photo gate speed. That's the initial speed of the two cars sliding together. And that, remember, you have to have in meters per second. Okay, so number 4, which method will you use? You can use either way that you'd like. The data, you need to have a table. We'll have a trial. The mass that's moving. Then you have a column that is the final speed or final velocity, initial velocity, and then the final force. Now that's if you're using this second method here. If you're using the first method with the video editor, then instead of the, let's see here, which one is it? Oops, I made a mistake. These are the columns you'd use if you are doing the video editor. We need one more column, and that would be the time. This is if you're using the first method. And I would like you to have 5 trials. 1, 2, 3, 4, 5. And then come up with an average force at the end. Now, if you're doing the second method with this equation here, we don't need the time. Instead, we need the skid distance delta x. Let's have each person have, let's have one sheet of paper for each lab group. I have 5 setups, so you'll have to divide that up. Please do not have more than 5 people in a lab group. You do not need to do the second page. The second side you can skip. When you are done with that, I want you to turn to homework C, the retake prep, and work on that. Everybody's going to be doing this because we are not going to be doing a quiz on this chapter. So this is the last whack at learning the material. So when you're done with the lab, please do homework C, the retake prep. Thank you.